Hi, we are SipSecure, and our mission is to create a reliable, easy-to-use device that detects common drink-spiking drugs. Drink spiking is a growing safety concern, and our project aims to give people a discreet tool to protect themselves and each other.
Our project scope began with understanding the community's needs. Through interviews and surveys, we learned that the top priority is reliability, followed closely by portability and ease of use. This feedback directly shaped our design goals.
We also conducted market and competitive analysis, and we found a total addressable market of $130 million. However, gaps in the market were that none of the devices on the market were multi-use and could be used more than once, and that is what we were hoping to achieve with our product.
On the chemical side, we're improving last year's molecularly imprinted polymer, or MIP, approach. Our goal is to engineer a polymer layer that selects for date-rape drugs like GHB, GBL, and ketamine to detect them at low concentrations.
We mapped out a full chemical process from polymer synthesis to electrode modification to drop casting and integration. This ensures every layer of the sensor is built with accuracy and reproducibility in mind.
Some of the biggest challenges we chemical engineers have faced thus far include labs and material access and optimizing the polymer chemistry. However, by working closely with our advisors, continuing with great team cohesion, and by optimizing our subsections, we've managed to push through and are still on track.
On the mechanical and electrical side, our team designed a compact device case using 3D printing. Our design keeps the device discreet, portable, and intuitive to use based on what real users said they wanted.
We also developed an integrated prototype that includes the LED as the indicator, the electrodes, and then the PCB, making sure it can all come together and test effectively, while the chemical and biological engineers ensure that the electrodes are set up for when we test.
One of the challenges has been aligning the geometry with the mechanical design, especially without a fully developed MIP, but we focused on maintaining a flexible prototype to evolve as the chemistry adapts.
The best part has been our collaboration, seeing the chemical detection system, the housing, and the electronics come into a single working device. We are excited to continue development next semester.
Together, we are building a device that merges science, engineering, and community safety. We're proud of our progress. We've committed to delivering a reliable prototype that can make a real difference. Thank you for watching.